Good morning, students. So in today's video I'll be discussing about sorting. In the previous video I discussed about linear search and binary search. So linear search and binary search are used when in an array you have to search for a particular value. So linear search, the data are in unsorted format. In bubble search, the data are in sorted format, that is in ascending order or descending order, like that, right? So using this sorting method, we arrange the array elements, okay, based on in ascending order or descending orders, okay. So there are different types of sorting methods used. So what is this sorting then? So like sorting refers to the operation of arranging data in some given order, such as increasing or decreasing with numerical data or alphabetically with character data. So as you know that in array we deals with numerical values, that is with digits, and then also with, it is also possible to deal with character values, right? So now what is this so what are different types of sorting methods? We have selection sort, bubble sort, insertion sort, merge sort. So we shall see all of this one at a time, okay. So the first one is selection sort. Now a selection sort is one in which successive elements are selected in order and placed into their proper sorted position. So what happens here in a selection sort? In a selection sort, if you see this pictorial diagram, okay, this is the name of the array is range, okay. So the size here is 1 2 3 4 5 6 7. So you have starting range is range 0 to range 6. So the maximum array element that can be created is 7. So as you can see, the data values here are unsorted format. You have to sort them out, right, from the lowest to the highest. So as you can see here, the lowest is 20. So what happens is that in a selection sort statement, okay, in array, okay, so here the lowest value 20, okay, will be compared with the first array element value, okay. So if this is lower, okay, so this will be shifted to the since this is the lowest value, okay, so this will be shifted to the first array element or the first array index, okay. And the value 90 will be shifted to this position, okay. So again, the in the second exchange, okay, the second lowest value will come and take the place of the second array element, okay. And then this value will go and take the place where the second least array element was present, okay. So this is how it takes place, okay. So the lowest value will be in the first array element. The second lowest value will come and join the second array element, okay, will be stored in the second array element. And the value which is stored in the second array element or third array element will take the place of the second lowest or third lowest, like that, okay. So here uh, see, when the elements are sorted in one-dimensional area from all the elements, the sorted procedure searches the smallest element, okay, the smallest element, this one, and the element is exchanged with the first element of the array, that is with this. 20 is exchanged with 90. Next, the second smallest element, that is 30, is searched and exchanged with the second element of the existing array, that is 40. So 40 will come and take the place of the last array element, and 30 will come and store in this second array element, okay. So for that we have a diagram here, okay, so that you can understand much better. So this is the first unsorted array elements, okay. So in the first exchange you can see that 20 has come and joined the place of 90, and 90 has uh, gone to the fourth array element position that was initially stored 20, right. So this is the first exchange. Now in the second exchange, as you can see that 30 has is stored in the second array element, and 40 goes to the last array element, which was where 30 was stored, right. So this becomes sorted out now. So next 40 comes here, okay, and in the place of 40, okay, 60, which was in the third array element, goes to the last position. Okay, then as you can see that 50 is the next lowest value, so 50 comes into the fourth position. Since the third, all the three array elements are sorted out, now the fourth array elements needs to be sorted out, so 50 comes here, and in its place 90 was there, so 90 goes into the place of 50. Okay, so as you can see that this goes on till all the array elements get sorted out. Now, what one thing you'll notice is that, okay, in each exchange, the number of array elements gets sorted out. Okay, the number of array elements gets sorted out. Okay, it forms like a step format, right? So what happens is that in every exchange there is one less array element to get sorted out. So you can see that at the last, okay, last exchange, you'll see that there are only two array elements left to be sorted out, that is between 90 and 80, right? So you will observe that in each pass, okay, there is one less array element left to be dealt with or to be sorted out. So what you will observe is that there are seven array elements or seven data values, okay, and the number of passes, the number of interchange, okay, is 6. So which you have learned that in your previous years also, right? The number of passes or exchange meant to be done, okay, is always one less than the number of array elements that are present, or the number of values that are present in the array, right? So this is how selection sorting takes place. Okay, so understand this theory concept very nicely. Okay, once you understand this concept, okay, doing the program will be very much easy for you. Okay, the programs here is same to the previous program that I taught. Okay, the program logic will differ a bit. Okay, so the variable names are means like are written differently. Okay, so for each program the variable names are changed. Now, so do a dry run method on this first. Okay, type this program and check the output that you get. Okay, so keep in mind that the array values that you enter has to be in unsorted format when you enter it. Okay, the program will sort it out and then it will give you in ascending order. Okay, next you have is the bubble sort method. Also that this also we have already seen in the previous years. Okay, so what happens in bubble sort method? Now also in bubble sort method you can see that the data are in unsorted format. Now in bubble sort method what happens is that, okay, the alternate exchange of the array element take place. Okay, so here the least number, okay, the starting from the first array element, okay, it will be compared with the second array element. Okay, so which value is lower will be exchanged. Okay, again the second array element will be compared with the third array element. Which value is lower will be exchanged and it will go to the second array element's position. Okay, similarly third will be compared with fourth. If it is lower, okay, then if the fourth is lower or if the third is lower, it will stay at its own place. Okay, then the fourth will be compared with fifth, fifth will be compared with six, six will be compared with seven, seven will be compared with eight, and so on. Okay, so by that time, okay, the lower values will be uh, sorted out, okay, and arranged into the starting array elements. Now for that, let me show you this diagram. Okay, so in the first one is unsorted, the data that are entered. So now in the first iteration or in the first pass, you will see that first 25 is compared with 57. So since 25 is lower than 57, 25 retains its own place, that is in the first array element or the first index. Okay, now 57 is compared with 48. Since 48 is lower than 57, 48 takes the place of 57 and 57 comes in here. Okay, now so first second, second, third compared. Now this 57 is here. Okay, 48 comes here. 57 is now compared with 37. Since 37 is lower than 57, 37 will come here, so it's written here. Now in its place 57 is here. Okay, so 57 has jumped from here to here, so 57 is here. Now 57 is compared with 12, so 12 is lower, so 12 comes and takes the place of 57, and 57 goes and takes the place of 12. Then again 57 is compared with 92. Since 92 is greater than 57, so 57 retains its own place. So 57 will be in the fifth array element and 92 will be here. Now again 92 is compared with 86, right? So since 86 is smaller than 92, so 92 comes, 86 comes, takes the place of 92 and 92 comes here. Okay, then again 92 is compared with 33, the last array element. Since 33 is smaller than 92, 92 takes the place of the last array element and then 33 takes the place of 92. So what you'll observe here in this purple sort method is that, okay, the maximum number, okay, in the first exchange, the maximum number goes to the last array element, right? What you have seen in selection sort is that the lowest value goes to the first array element, right? The minimum value, uh, in the first exchange, it goes to the first array element. But here, quite the opposite happens. The highest value goes into the last array element in the first exchange. Now, in the second exchange, you will see that, okay, again, 25 will be again compared with 48. Since 25 is less, so 25 retains the place. 48 is compared with 37. Since 37 is less, 37 comes here, 48 goes here. 48 is again compared with 12. Since 12 is less, so 12 comes here and 48 goes here. 48 is compared to 57. Since 48 is less, 48 retains its own place. Now 57 is compared with 86. 57 is less, 57 retains its own place. 86 is compared with 33. 33 is less, 33 comes here, 86 goes here. Then 86 is compared with 92. Since 86 is less, 86 stays here. So in the second iteration or in the second pass, you will see that the second maximum number goes to the second last array element, right? So this process will keep on going, okay, till, okay, the elements also get sorted out from ascending to descending order. Okay, so it is pushing the values, okay, it is pushing the maximum values to the last array element and it is pushing the minimum values to the starting array elements. This is how the concept of purple sort method works. Okay, so try to understand this diagram very nicely. From if you understand this one, okay, uh, then the programs will be much more easier for you. Okay, so type out this program with the dry run method on it, okay, and then find the output on this also. Okay, so next we have is the insertion sort. So this insertion sort also, okay, you have a diagram in there. Okay, so now insertion sort is one that sorts a set of records by inserting elements into an existing sorted list. Okay, so here what happened is, okay, uh in both the previous sorting method, okay, once the array elements get sorted out, okay, once the array element gets sorted out, that is here, okay, once they are sorted out, okay, their position remains undisturbed, right? They stay constant, right? They stay constant. So but in insertion sort method, okay, what happened is that, okay, here you can see that they are all unsorted, right? Now the first position is considered as a sorted array, the first sorted element. Okay, so now you can see here these two are sorted out. Okay, but what happened is that in insertion sort method, okay, though they may be though this may be sorted arrays, okay, yet, okay, the unsorted values are compared with and inserted into the sorted arrays, okay, based on the uh, least values. Okay, so it can be inserted into the sorted arrays also. So as it is written here, uh, is one that sorts a record by inserting elements into an existing sorted list. Okay, when the number of values is stored in an array, they are treated as either sorted elements or unsorted elements, right? But as insertion sort considers any one of the element is picked and place in the sorted part of the array. Okay, this one. But as insertion sort, consider any one of the element that is this ones, okay, is picked and placed in the sorted part of the array. So like here between 40 and 60, right? 40 and 90, 60 is picked from here and inserted into the already sorted array list. Okay, so as you can see in this diagram, okay, so the first array element here in this case is considered as the sorted array element. Okay, so now what happened is that, okay, it will be compared with this next array element. Okay, it will be compared with this next array element, so that is 40. So here, since 40 is less, so 40 takes the place of 90 and 90 takes the place of 40. So this is after the first exchange. Okay, now these are the unsorted array elements now. So these values will be compared with these sorted arrays and inserted in the sorted array list. So it will take the place of 90, and 90 will be pushed into the place of 60. So now this becomes sorted out. Though this is sorted out, but this is temporarily sorted out only, because you can see that 40, 60, 90, yet there are numbers which are less than that also, right? So in the next place, as you can see that 20 is the minimum value, right? So this 20 is compared with 90, and since it is smaller, okay, it comes here. But then again it says that 60 and 40 is larger than 20, right? So that's why in the third exchange, 20 takes the first position, and in its place, okay, the sorted arrays are pushed one step down to the next array element. So 20 takes the first uh, index, the first array element, okay, is stored in the first array element. 40 is stored in the second array element. 60 is stored in the third array element, and 90 gets pushed to the fourth array element, that is the place of 20. Okay, then after that, this will be compared. This unsorted array list will be compared in the sorted array list. So now, since 80 is compared to 90, 80 takes the place of 90, and 90 takes the place of 80. Okay, so as you can see that these are already sorted out, yet there are values that are still can be less than the 40 or 60, right? So now 50 is compared with the sorted list. So now 50 is compared here, and then since it is less, and then it is less than here and less than 60, so 50 takes the place of 60. Okay, and then the larger numbers are pushed one step into the next array element. Okay, so now here, as you can see that, okay, 90 takes the place of 50, and 50 comes and takes the place of 60. Okay, and 60 and 80 are pushed. So again 30. So this is the last unsorted array list. So this will be compared with the sorted out array list. So now automatically it comes in and joins into the second array list, right? So this is one another method of insertion sort method. Okay, so here you can see that the data are arranged much more faster and more easily, because it is compared with the sorted array list, right? So since it is compared with the sorted array list, okay, so the unsorted array values can be arranged much more faster, since it is in a sorted list order. Okay, so go through this diagram, okay, and then go through these diagrams, go through this paragraph, okay, try to understand this concept, okay, and after that, okay, try the programs, okay, and then do a dry run method on it, and then find the output. Okay? So if you have any problems on the programs, okay, yeah, you can always contact me, okay, and then I'll explain to you in that format. Clear? So that will be all for today.